Hello everyone and welcome to yet another episode where we shall be looking at the preparation for the grade 10 mathematics, okay, term 1 test, okay. So with me I have a number of papers that's from 2023 up to 2025 that we can use for our preparation, okay. I know between those years quite a lot has changed, and as per the teaching plan of this term, there is quite a lot that we should expect. Number one, we have the number types or the types of numbers. Okay. Number two, we should expect number types, the rounding off, and how you work with the numbers, rational and irrational, all those aspects in the first one. Then the second one, we can have our exponents, okay, indices, those are basically the surds and so on. Number three, there should be something to do with equations and inequalities. Okay, so with grade 10s, we also expect to have something like trigonometry for term 1. Okay, so depending on when your test is going to be due. Okay, so for those that are writing the test towards the last weeks, then trigonometry should be part of it. And then for those tests that come before the trig topic, basically anything that is less than the trig. Okay, so besides the exponents, besides the indices, rounding off and all of that, I think we shall look at all the other aspects that I may not have mentioned here within the paper, and then as the questions unfold. Okay, so with the first question or with the instructions, we have 10 questions that we're going to answer. Okay, just please follow through with me. I'll try to be as brief as I can, and I'll try to be as detailed as possible for at least everyone to understand. Okay, so what we need to do here is, okay, so let's see. Normal instructions as per the question paper. Okay, let's just revise through them just now so that we can be sure. Okay, so all answers, okay, all questions need to be answered. Appropriate correct numbering system must be used. Okay, clearly show all the calculations. And then answers only, do not guarantee full marks. Approved calculator. So we use a calculator in grade 10, okay, for as long as not programmable. And then if necessary, answers should be rounded off to decimals, okay? So in most cases, unless the question tells you to do otherwise, okay? All right, then question number one, that we were saying that we must round this off to 3 decimal places. Now, whenever you're rounding off, since the question stated 3 decimal places, so a decimal place is basically a number that comes after the comma, okay? So we're talking of position number 3 after the comma. So it's 1, 2, 3. Okay, so 6 is in the rounding position, and then we need to look at which digit comes after 6. It's 8. So 8 is going to affect the 6. It's going to increase it by 1. What does this mean? That digits between 5 and 9, for as long as they come after the rounding position, they increase the value in the rounding position by 1. Digits between 0 and 4 do not affect, which means it will stay the same. So in this case, we're going to have 4, 3, 7. Now the 6 is going to become a 7. So that becomes our answer to 3 decimal places. All right, then 1.2, given that S is the square root of 2p over t, if t is 12 and p is 132, can we determine the value of S? Meaning that we need to do the substitution. So it's going to be square root 2 times 132 divided by 12. Okay, so when you simplify that, I'm getting 11. Is it 12 over 11? No, not really. Cannot be 12 over 11. It's like a 22. So 2 times 132 over 12 is a 22, which means it's the square root of 22. They said leave the answer in a surd form. So a surd form is whereby we have the square root as part of our answer. Do not press the SD to get the decimal. Okay, can we state whether S is rational or irrational? Now, since 22 is not a perfect square, I mean, we cannot even get the square root of 22 to get a whole number, which means this answer is irrational. And then between which two integers does S lie? Remember, S is representing this. Now, whenever you're looking for integers where a certain surd lies, if it's a square root, then we're going to look at square numbers. Remember, square numbers are basically natural numbers squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, and then 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on. Now we see that this 22 simply lies between 16 and 25. So we can say that 16 is less root 22 is less 25. And then we find the square roots of those numbers. So square root and square root. So square root of 16 is a 4, less root 22, and then less 5. So it's between 4 and 5. So if 4 is an integer, 5 is also an integer. All right, then 1.3, can we rewrite 1, comma, okay, it should be 1, comma 1, 4 with a dot on top. So what the dot means in mathematics is that that number is recurring. Okay, so the dot on the 4 is the same as 1, comma 1, 4, 4, 4, and so on and so forth. So what this is going to be, or what this is going to become, is that we normally let any letter of your choice, let's say y, be equivalent 1, comma 1, I can say 4, 4, 4. Let me just use three 4s, okay, continuously. Then I need to cover the first digit that is not repeating. And every time the comma moves, it's a multiple of 10. So 10y is equivalent to 11, comma 4, 4, 4 recurring. Okay, then I also need to cover the digit that is repeating, which is just the 4, meaning that I'm going to multiply by 10 again. So this one multiplied by 10, which makes it 100y, is equivalent to, what is this one going to become? 1, 1. When the comma goes that side, it's a 4, comma, the 4, 4 recurring. Okay, so this was equation 1, this was equation number 2, this is equation number 3. So all I have to do is get equation number 3. Okay, equation number 3 minus equation number 2. So 100 minus 10, that's going to give me 90y. And then 114 minus 11, which gives me 103. The comma 4s will cancel out. So I have 90y is equal to 103. Then I'll divide both sides by 90. Then 1 over 3, or 103 over 90. This cancels that, which means we have 1 over 3 over 90. These two numbers, there's nothing common. I mean, there's nothing that can be used to reduce this. So this should become our answer. Okay, you can confirm that by punching it in the calculator and see if we're going to get the same answer, which is 1,14444. Okay, so that is how we do that if there's a number that is missing or a number that is not recurring. All right, then we move on to the next question, which is question number 2. Expand and simplify. When they say expand and simplify and you have brackets, we have to open up these brackets. Okay, that's the meaning. So you have different methods of how you open your brackets, but I'm going to use the simplest. So I'm going to get this 3a is going to affect everything within this bracket. Then the 2b is also going to affect everything within this bracket. So I'll say 3a into 2a squared minus 4ab plus 5b squared. And then plus the 2b into 2a squared minus 4ab plus 5b squared. Okay, let me open up now. So 3a and 2a squared gives me 6a cubed. 3a and 4ab gives me minus 12a squared b. 3a and 5b, that's going to be a 15ab squared. Okay, then 2b multiplied by 2a squared, that's going to be a 4a squared b. A 2b multiplied by negative 4ab, that's going to be negative 8ab squared. Then a 2b multiplied by 5b, we get a 10ab b cubed. Do we have any like terms? Yes. We have this a squared b, a squared b, ab squared, ab squared. So we're going to have 6a cubed. Okay, so minus 12 and 4 is going to give us just minus 8. And then 15 minus 8 is going to give us a plus 7. And then plus b cubed. So this becomes our solution. All right, then 2.2, simplify the following expressions. So grade 10s, whenever they ask you to simplify and we are saying this sort of fractions, okay, with variables, the first rule that must come to your mind, or the first instinct, you have to factorize, okay? So this is a trinomial. This is a difference of two cubes. This is a binomial. This is a trinomial as well, okay? So let's see. We know that with this trinomial, the product is -6, the sum is a +1, meaning that's going to be x plus 3, x minus 2. And then at the bottom here, difference of two cubes, why don't I just write it here? So x plus 3, and then x minus 2. Difference of two cubes, we said it's going to be 2 minus x. And then we open up this, we square the 2, which is a 4. You multiply 2 and x, and then we square the x. All right. Then we don't divide fractions in maths. We change the sign to multiplication, and then we flip this around. Okay. I'll start with the bottom part. I need to factorize that. It's going to be a 2 into x plus 3. And then when I look at this, product is 2. Sorry, product is 4. The sum is 2. There's nothing. I cannot factorize that. So I'll leave it as x squared plus 2x plus 4. Then our next step is just mix masala, just cancel out. So this cancels that. Remember, it's the brackets that cancel. Okay, this bracket here will cancel the whole of that because it's also some sort of a bracket. And then 2 minus x and x minus 2. Well, these two kind of look the same, but there is something funny. The 2 here is negative, the 2 here is positive. So for us to create similarity, we need to factorize the negative sign from the top or from the bottom. So I'll have 2 minus x over 2 into 2 minus x. Then this cancels that. Whenever I cancel everything and disappears, I'll be left with a 1. Okay, meaning that our answer is -1/2. All right, so that is that. Then 2.2.2, this is exponents, okay? This is an exponential question, and we know that with exponents, the target is to create the same bases, okay? So let's write it this side and say, we have 2 to the 2n, okay? We are multiplying it by 4 to the n, and then multiplying it by 2. All over, this is going to be 16 to the n. Okay, so if the bases are different, create similarity. So this is going to be 2 to the 2n. 4 can be written as 2 squared. But then if there is n, then becomes 2 to the 2n. We are multiplying it by 2. 16 can be written as 2 to the 4. But with the n, becomes 2 to the 4n. Okay. And then let's apply the laws that when we are multiplying the same bases, we add up the exponents. Then when you're dividing, you subtract. So it's going to be 2n plus 2n plus, there's a ghost 1 then. And then we are subtracting this bottom part, which is 4n. So 2n and 2n is going to be 4n plus 1 minus 4n. The 4n and the 4n will cancel. We are just left with the 1. So 2 to the 1 is the same as a 2. All right. So that is 2.2.2. And then 2.3 is factorization, okay? So from grade 9, we've been learning about factorization. We have different methods of factorization. And now at this point in time, you should be able to tell which method is needed at what point. So when you look at 2.3.1, x is squared, but we know that 1 is also a square because 1 squared is 1. So meaning that this is a difference of 2 squares. So with the difference of 2 squares, all you have to do is open up 2 brackets. Okay, one bracket will have a plus, one bracket will have a minus. Then what is the square root of x squared? It's x. Square root of 1 is 1. And then the same things, but different signs. And then you're done. Those are your 2 marks. All right, and then 2.3.2, we have p squared, and then plus p into 4 plus q, and then a 4q. So what I'm going to do here, I mean, it looks like a quadratic, but it's going to be a bit hard for me to tell the product and the sum. Rather, let me open this. So it's a p squared plus 4p plus pq plus 4q. I have 4 terms. Now with my 4 terms, I can now, whatever, I can group them. What's common here? It's a p. I'll be left with p plus 4. What's common here? It's a q. Then I'll be left with a p plus 4. So with the grouping method, the aim is to get the same bracket again. Okay, so take out that same bracket, which is a p plus 4. When p plus 4 is removed, we are left with a p. When p plus 4 is removed, we are left with a q. Okay, so that is how we obtain that. Okay, so those are 26 marks in the bag. All right, then question number 3, we have solve for x. So this is specifically to do with the equations, okay? Solve for x, so they're telling us that 3.1.1, this is a linear equation because exponents are just 1, 1. So with linear equations, the aim is to create or to isolate the unknown. So move this 4 to that side, move this 2 to that side. So it's gonna be 4x becomes positive. Ne? The 3 is still negative, is equal to 6 minus 2. So 4x minus 3x is gonna be x. 6 minus 2 becomes a 4. That's our answer. And then 3.1.2, this is a quadratic equation. So with the quadratic, we have to factorize. Ne? So look for your product, look for your sum. So the product is negative 35, this one. And then the sum is at negative 2. So which 2 numbers do we multiply to give us negative 35? But when we plus them, we get a negative 2. That's going to be negative 7 and a 5. Ne? So we're going to say x minus 7, x plus 5 is equal to 0. And if that is the case, we just flip this around and say x minus 7 is a 0 or x plus 5 is a 0. Meaning that the first x is a 7 or this x is a negative 5. All right, so those are the 2 answers that we expect with that question. Then 3.1.3, this is an exponential equation. Remember, with exponential equation, the bases have to be the same. That is the rule, okay? So this 27 can be written as 3 cubed. So I'm going to say 3 cubed with x minus 2 is equal to 9 is 3 squared, okay? But we are multiplying with a 3. So let's drop the bases and equate the exponents. So it's going to be 3x minus 3 times 2 is a 6, ne? Is equivalent to 3 times 2, which is a 6. Ne? Then move this one that side. 3x is going to be 6 plus 6, which is a 12. Divide both sides by 3. X becomes a 4. All right, so that is how we get that. All right, let's follow through. 3.2, which is the linear inequality. So just like the equations are, even the inequality, the way we solve them is the same way we solve that. The only difference is that there is always that extension of the number line, okay? So let's open this bracket. 2 and 2x is gonna be 4x. 2 and 3 is gonna be a 6. You're subtracting 4. Where on time move this one this side. Minus 2x is greater or equal to 0. So 4x minus 2x is going to give me 2x. Minus 6 minus 4 is minus 10, is greater or equal to 0. Let's move the 10 that side, meaning that 2x is greater or equal to 10. Divide both sides by 2, x is greater or equal to 5. Okay, so this is what we end up with. But then there is the part of the number line. So with the number line, this is what happens. If you have, let's say, an equal sign, then the dot needs to be closed. If there is no equal sign, the dot will be open. Now, since x is greater than 5, we're looking for all numbers that are bigger than 5, and those numbers are found to the right of 5. So we draw our arrow in that sort of direction. So that is how we answer 3.2. And then 3.3, we have some farmers here, okay? So they're telling us that a farmer buys a total of 37 sheep and goats. He pays 115 per sheep, and then he pays 250 per goat. How many sheep did he buy if he spent a total of 6145? Okay, so this is more like a simultaneous equation, but let's see. He bought a total of 37 sheep and goats. So meaning that we don't know how many goats are there. We don't know how many sheep will be there. So I'll let X be the goats, né? Because they're always lost. Well, X is always lost. You have to find it, né? And then let the Y be the sheep. Okay, so meaning that 37, meaning that if we get X plus Y, we must get a 37, okay? And then 115 per sheep. So it's gonna be 115 multiplied by Y. Plus the goats are 250. This is gonna be 250 of X. Must give us a total of 6145. Okay, so this is a typical simultaneous equation. So question 1, this is equation number 2. So what we need to do, we can use elimination, okay, or you can use your substitution, depending on what you were taught at school, okay? So if I multiply through by 115, it's going to be 115x plus 115y. What is 37 times 115? It becomes 4255, no? This is equation number 3. Then I need to subtract. So 250 minus 115 becomes 135x. This cancels out. So 6145 minus 4255, I get 1890. Okay, there when I was born. Okay, then we are dividing both sides by 135 and then 135. Okay, so x becomes 1890. Okay, my birth year over 135. No, we said 135, which is 14. Oh, okay. So we have 14 goats. No, did we say goats? Yeah, 14 goats. Meaning that the sheep, which will be Y, is gonna be 37 minus 14, which must give us what? 23. Ne? All right, so we have 23 sheep and then 14 goats. Okay, so that is how that question was supposed to be answered. I don't know why they gave you simultaneous in words and then they also gave you the simultaneous in okay, it was the discretion of the examiners. 3.4, solve for A. So this is for part of what we call the literal equations. Okay, so in these equations, we're just solving unknowns, making unknowns the subject and so on. So when they say solve for A, you must leave A on one side. So let's move the U that side. So it's gonna be V minus U equals to 80. Then divide both sides by T, divide both sides by T. So meaning that our A is a V minus U over T. And then that becomes the answer. All right, then 3.5, they want us to solve simultaneously for X and Y. So I'll still use the same method that I used. which is the elimination. So if I want to eliminate x, I have to make sure that the number before x is the same for both equations, okay? Equation 1, equation 2, we start with baptizing. Okay, so for us to get the same value, we're gonna get the first equation, multiply it by 2. So for it to create similarity, we always use multiplication and division. Okay, so what is the equation gonna become? It will be a 2x minus, that's gonna be a 4y is equivalent to 0. This is our equation number 3. Now, since the signs in front of what we want to eliminate are the same, okay, so we are saying that if the signs are the same, we subtract. If the signs are different, we plus. But this applies to what we want to eliminate. Okay, so we said we are subtracting. So 2x and x is 0. And then minus 3y minus 4y gives us a y. Okay, it's a negative 3y minus 4y. This becomes a positive, and then that is that. And the negative 1 minus 0 is a negative 1. And then we're done pretty much, okay? And then we need to get the value of x. Okay, so for us to get x, you can substitute this into one of the equations, okay? Where there is y, I put a negative 1. I'll use the first equation and say x minus 2 into negative 1 is 0. X plus 2 is going to be a 0. Move the 2 that side, meaning that x is a negative 2. So that is how we claim the 5 marks, okay? Don't mind the disorganization, but the steps of how we got that. All right, so that brings us to the end of the first part, okay? Then we're going to the second paper, which was probably a 2024 paper. Now, as you can see, that the format is just typically the same. The first question that side was rounding off, and then this the rational numbers and blah, blah. It's the same thing here. Okay, so meaning that if I'm to become a prophet, I could say even the paper that people are gonna write is gonna be like this. I don't know, okay? Don't want to be a prophet of doom. All right, so round off to 2 decimal places. So remember decimal places, those are numbers after the comma. So we're looking at 2 numbers after the comma. So we have 7, we have 9. What comes after the 9 is a 7. So 7 is going to affect the 9 by adding a 1. Okay, so we know that 9 plus 1 is a 10. So 0, you carry 1. 7 and 1 is going to give us 8, comma, the 1, 9. Meaning that our answer is approximately 19,80. That's one mark. Then 1.2. 1.2. They're telling us that for which value of values of t is the expression. Okay, this entire expression is t. And then they gave us a list to choose from. Okay, so where do we find the number to be rational? Remember, a number is rational if we can find its square root. That is if the number, whatever is, if we have a surd. Okay, so if we can find the square root of whatever is inside there, then the number is rational. So in this case, if we put a negative number, a negative 2, it's not going to give us what we want. But if we put a 1, or replace x with a 1, so it's going to be 50 over 2, which is a 25. We can find the square root of 25. So meaning that x is going to be a 1. And then which number or which values of x can we replace there for the equation to be irrational? So irrational simply means that whatever is inside of the root is positive, but we cannot find the square root. An example, if x is a 0, it's just going to be square root of 50. 50 is not a perfect square. We're going to have a lot of decimals. So x is a 0. And then also if x is a 2, 50 over 3 is an irrational number. So x is a 2. So 2 marks for 2 answers. 1 mark for 1 answer. Now we know the trick. Okay, where x is a non-real number, we need 2 answers. So non-real number simply means the result of everything here must give us a negative. Okay, so if we replace x with a negative 3, the bottom part is going to end up being a negative 2. 50 divided by negative 2, we get a negative 25. So that is irrational. So x is a negative 3. Okay, and then x is also a negative 2. It also becomes non-real. All right, and then maximum value, meaning that what is the highest value that we can ever get from here if we do the substitution. So with -3, -2, and -1, we're not necessarily going to get any answers because either the part is going to be undefined or the system is going to be non-real or something of the sort. So meaning that we need to choose from 0, 1, and 3. Now, the higher the number that we use, the more it increases the denominator. And the moment the denominator becomes bigger, then the value of the entire system becomes smaller. Our interest is the maximum, meaning that if x is a 0 here, then you're going to have a 50 over 1. Square root of 50 is bigger than just replacing x with a 1 to give you the square root of 25, which is also bigger than the square root of 50 over 3. So meaning that x needs to be a 0. Then 1.3, determine without the use of a calculator between which two consecutive integers. Consecutive means one after the other. Where does cube root of 20 lie? Now, first part, we use the square root. Okay, we looked at the square numbers. Now here we have in cube root, which means we're going to use the cube numbers. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Where do we find 20? 20 is between 8 and 27. So we're going to say 8, you can say cube root of 8 is less the cube root of 20 is less the cube root of 27. So the cube root of 8 is 2. Okay, and then it's a 3. Why am I writing 8? Hey, Baba. It's supposed to be a 2. Now it doesn't want to erase. I want to remove the evidence. Okay, so it's a 2. Okay, 2 and then a 3. So those are the only values that are consecutive. Okay. Then 1.4, can we prove that 1,31 is rational? Okay, let's prove that 1,31 is rational. Okay, so what we said was that if we have something like that, let me just go this side. Now you see that this question just looks more or less the same as what we had. It's 1,14. So it's these two numbers that are recurring. Now it's 3, 1. You see now? Let's just take this out. 1,31. Okay, so we're gonna say let's use m this time around. 1,31, 31, 31, and so on. So in this case, straightforward, there is no number that's not repeating. All numbers are repeating, like the two numbers after the comma. So we're gonna multiply it by 100 on either sides, okay? So it's gonna be 100m is equal to 131,31, and then 31, and then 31. This is equation number 2. Get equation number 2 minus equation number 1. 100 minus 1 is going to be 99m. 131 minus 1 is 130. The rest will die out. Ne? So m becomes 130 over 99. Are there any numbers that we can divide the two? No numbers. So that becomes the rational part. So we have proved that indeed this number is rational. All right, then question number 2. They're telling us to expand. Remember what we said. Expand and simplify means opening the brackets. Okay, so in this case, we have a 3m into m plus 2n minus 5. And then it's going to be minus 2n into m plus 2n minus 5. So 3m and m is going to be 3m squared. 3m and that's going to be 6mn. 3m and that is going to be negative 15m. Minus 2n and m is going to be minus 2mn. This and that's going to be minus 4n squared. And then minus 2 and minus 5 is going to be a positive 10n. Do we have any like terms? It's just this and just that. Meaning that is 3m squared plus 4mn minus 15m minus 4n squared plus a 10n. That becomes our final answer. Then 2.2, simplify the following expressions. So still the same story, né? Whenever they say simplify and you have such fractions, we factorize. Take out what is common. Okay, so with the first part here, we can see that 4 is common. These are two numbers. So 4, we're going to have x plus 2. Over, this is x squared minus 4. This is a difference of 2 squares, meaning that we're going to have x minus 2, x plus 2. We do not divide fractions once again. Change the sign to multiplication. This must go on top. This must come down. So it's going to be x minus 2. Know that x to the 0 must always be a 1. And then what comes next? Makes masala. So this cancels that. And then this one will cancel that. You're only left with 4 over 1, which is the same as a 4. Okay, and then 2.2.2, exponents. Remember the rule of exponents? Create similarity within the bases or break down the bases. Now we know that 25 can be written as 5 squared, né? But we have a negative x, so I'm going to say negative 2x. And then 15 can be written as 3 times 5, everything to the exponent of x plus 1. Then we distribute that. It's going to be 3 to the x plus 1, and then 5x plus 1. Over, this is 3 to the x, times 5 to the negative x. Let's apply the laws, okay, only for bases that are the same. So it's a 5 minus 2x, okay, plus the x plus the 1. But now we are subtracting. So minus x. Let's look at the 3. It's going to be x plus 1. And then we are subtracting the x. Okay. So we know that this and that is going to give us a plus x. So 1x and 1x becomes 2x's. So it's going to be like minus 2x plus 2x, which is like a 0. No? So 5 to the 1 times 3 to the 1, because this x is going to cancel that x. And then our answer becomes just a mere 15. Okay, so question 2 is answered. We go to question number 3. They want us to factorize fully. Okay, so this is a difference of 2 cubes. What do? We find the cube root of 27 is 3. The cube root of that is x. And then you square the 3, you get 9. You multiply 3 and x, 3x. You square the x, that's going to be x squared. Okay, so when you're subtracting cubes, the first bracket is a subtraction. If you're adding the cubes, then the first bracket is going to be addition, and then 9 minus 3x plus x squared. Okay, so pay attention to the signs and how they work. And then 3.1.2, we have 4 terms, and with 4 terms, we said we must always group. So this and that, I'll group this and put a plus sign there. What's common in the first bracket is n squared. I have n minus 1. In this bracket, let me take out the negative so that I have n minus 1 again, because I want similarity. Okay, so n squared minus 1 into n minus 1. This is a difference of 2 squares, so n plus 1, n minus 1, and then this last n minus 1. Okay, so this is giving me both these brackets, and then this third one. All right, then 3.2, which is very challenging. How do I work out this question now? Let's see. So please don't laugh at me if I get stuck, né? Maybe if the question becomes hard. So they're telling us we have x to the negative 1 plus x is equal to 6. Is that true? Yes. They want us to prove that x to the negative 2 plus x squared is equal to 68. But there are 2's everywhere here. Okay. That is very correct. So one thing that we don't see here is that we don't have the 2 and we don't have the square. So meaning that we need to square, and then we need to introduce the 2's. So it's up to you which one you want to do first. But I think I'll have to square first. Okay, so that's going to be 1 over x plus x. I'm squaring that, and then I'm squaring that. And then this is a FOIL whereby I'll have the same bracket twice. So 1 over x times 1 over x is going to give me 1 over x squared. And then 1 over x, oh, grade 10s prefer seeing what we are doing. Okay, so we are saying 1 over x plus x. 1 over x plus x. So we are saying 1 over x times 1 over x. We get this. Then 1 over x times x, okay, it's going to give us a 1 because the x's will cancel. And then x times 1 over x is also 1. Then x times x going to give us x squared. 6 squared is a 36. Okay, let's play around with what we have. So it's going to be 1 over x squared plus a 2 plus x squared is equivalent to 36. Let's move this one that side. 1 over x squared plus x squared gives us a 34. Then we said we're going to introduce the 2, so multiply through by 2. So 2 over x squared, 2x squared is equal to 68. Okay, but we know that if we change this back to the original, it's going to be just that, the way they want it. Okay, there we go. We've proved it. Okay. Question number 4. These are linear equations. Okay. Linear equations for 4.1.1. Move the x that side, move the 5 that side, which means 3x plus 5x is equal to 7 plus 5. That's 8x is 12 divided by 8. So 12 over 8 is the same as 3 over 2. And then number 4.1.2 is a quadratic. Remember, quadratic, we need 2 answers. So that is x minus 2, x minus 1. So this bracket gives us x to be a 2. This bracket gives us x to be a 1. So those are the 2 answers as well. Remember, it's the product and the sum. And then 4.1.3, which is the exponential. With exponential, create the same bases. So that is 2 squared, x plus 2. This is 2 cubed with x. Drop the bases. 2x plus 4 equals to 3x. Move this one to that side so that we have a positive x there. So 4 is the same as x. Therefore, x is what? Is a 4. Okay, 4.2, this is an inequality of a fraction. This is 3 and 2. Whenever you have fractions, try to eliminate the denominators. What is 3 times 2? It is 6, meaning that I'm going to multiply this side by 6. I'm going to multiply this side by 6. So 3 divided by 3 is 1, 6 divided by 3 is 2. 2 divided by 2 is 1, 6 divided by 2 is 3. Then I'll open up. 2 by 2, it's going to be 4x. 2 by 1 is a 2. 3 by x is 3x. 3 by 3 is a 9. Let's collect the like terms. So 4x minus 3x is 9 plus 2. So meaning it's x is greater or equal to 11. But they want a number line. Remember, greater should always be to the right. All right. And then 4.3, they want us to solve for h. So when you're solving for h, you're making h the subject. Okay, so j is equal to h squared w. Let's cross multiply or multiply both sides by w, meaning h squared is the same as jw. And then we need to find the square root to leave h alone on one side. So that becomes our answer. Start by multiplying by w, then with w. So this cancels that. To get rid of the square, you must find the square roots on either sides. All right, 4.4, solve the simultaneous. Y is x, x is y. Then we substitute. So where there is y, put x. 6x minus 15. Move this one that side. It's going to be x minus 6x is equal to negative 15. So this is a negative 5x is negative 15. Divide both sides by negative 5. X is a 3. Okay. But then they told us we must find x and y. Since we said y is x, x is y, meaning that y is also a 3. All right, so that brings us to the end of the second paper. All right, let's have the last paper, okay? And I believe that by the time we finish this paper, we should be ready for the tests, okay? All right, let's see. Okay, they want us to round up to 3 decimal places. So we said 3 decimal places, 3 numbers after comma, so 7, 3, 0. What comes after the 0? It's a 9. 9 is going to affect the 0. So it's going to be 9, 4, 3, 7, 3, 1. Okay, that's the answer. And then 1.2, they're telling us that if k, okay, is the square root of everything here, and our a is 8, x is 1 over 3. They want us to get the value of k. So just substitute, guys. 2 times 8 over, that's going to be 3 times, it's 1 over 3 squared. Okay, so that's going to be square root of 16 over 1 over 3, which gives us square root of 48, if I'm not mistaken. Okay, so since they want the whatever, they want the value of a, we can leave it like that. That is one version of it. Alternatively, you may change it and simplify it, but I prefer to leave it at this point, because if you simplify that, you're gonna get something like 4 times the square root of 3, which is something that is a bit abstract for the grade 10s. So rather, we leave it the way it is, square root of 48. So is k rational or irrational? So this entire thing represents k. So this number is irrational because we cannot find the square root of 48 to give us a whole number. Okay, then between which two integers does k lie? Now remember, this is a square root, and with the square root we must use the square numbers. So 1, 4, 9, 16, 25, 36, 49, and so on. So meaning that 48 is between 36 and 49. So square root of 36 is less root 48 is less root 49. Square root of 36 is a 6 and then a 7. So between 6 and 7. 6, 7. Okay, 1.3. Convert 0.396 recurring to a common fraction. So 3, 9, and 6, they are recurring. So what did we say we do? So we're having 3 numbers that are recurring. So let probability be equivalent 0.396, 396, and so on. Then since it's 3 numbers that are recurring, and we don't have anything that is not recurring in front or after the comma, we're going to multiply directly by 1,000. We need to move this comma to cover the numbers that are repeating. So we're going to have 396, 396, and 396, and continuously. Equation 1, equation 2, get equation 2 minus equation 1. 1,000 t minus 1 t gives us 390 is equal to 396. And then we're going to divide both sides by 999, okay? So 396 divided by 999. Is there anything that can divide to reduce that? Yes, if there's anything, then we need to do that. So if I punch that in the calculator straight away, it reduces it to 44 over 111. So that is what we have to do for us to get those marks. All right, so 10 marks in the bag. Question number 2. Question number 2. They are telling us that we must. Okay, so question number 2, they are telling us to expand and simplify. Instructions are still very clear. Expand, simplify, you open the brackets. So it's going to be 2x and 3, which is going to be 6x. 2x and x is going to be 2x squared. Plus x and 2x is going to be 2x squared. X and the 5 is going to be minus 5x. So what we are seeing is that we have 2x squared. This is positive 2x squared. So these two are going to cancel out. We're going to be left with 6x minus 5x, which is just x. Okay. Then 2.1.2. What do we observe before we open up? Yes, so you can go ahead and open everything. But when you look at the tool, this is p minus 2 over q. Then they squared this to p squared. They multiplied these two to p over q, and then they squared this to 4 over q squared. Meaning that this is a difference of 2 cubes. So it's a p cubed minus 2 cubed is going to be 8. So it's going to be 8 over q3. So that is the answer that we have. Yes, you can do the simplifying of opening the brackets, but even the answers only can give you the full marks in this case. All right, then 2.2, simplify the following. So we have some exponents. Let's multiply coefficients first. So 2 over 7 times 7. And then the bases are the same here. We shall have to add up the exponents. That's a x to the 5. So this 7 cancels that 7. And then we only left with 2a x to the exponent of 5. And then 2.2.2, let's divide the coefficients only. And then when you look at the x's, we have more x's at the bottom. When you look at the y's, we have more y's at the bottom. Meaning that 3 divided by 3 is going to be a 1. 12 divided by 3 is going to be a 4. And then x, going to have 6 minus 2. Y, 3 minus 3. So that's going to be 1 over 4. That's going to be x4, y6. Okay. And then 2.2.3, we have this fraction. Okay, so whenever we have fractions, factorization is the way. Okay, let me write it that side. We have 3xy. Okay, so 3xy over x cubed plus y cubed, but we are plusing 1 over x plus y. So in this case, since we are adding fractions, we need to do the crisscross. So this multiplies with that, multiplies with this. If you have more than 2 terms or more than 1 term, put the brackets. Okay, so x, so we're going to have 3xy into x plus y. Plus, this is going to be x cubed plus y cubed over, I don't need to open this up. I'll just leave it the way it is. Okay, then let's take out what is common, or do we need to open? I don't want to open this. I would rather expand this. So 3xy into x plus y. When we look at the difference of 2 cubes, the sum of 2 cubes, it's going to be x plus y into x squared, xy, and then y squared. This is being divided by x plus y, and then x cubed plus y cubed. We could have it, but I don't want to. What's common here? We can see the x plus y and x plus y is common. Okay, take it out. So x plus y is out. I'll be left with the 3xy plus x squared plus xy plus y squared. Dividing this by x plus y into x cubed plus y cubed. Is this taking me somewhere? So I can cancel this out. And then I'll only be left with x squared plus 4xy plus y squared over x cubed plus y cubed. I think that is all that I'm getting. Yeah, so I'll stop at that. Then 2.3 factorized, difference of two squares is going to be x minus 5 and then x plus 5. And then 4 terms, we just need to group. Okay, when you're grouping, what's common here is the 3, but x. You'll be left with a 2b minus 5c. Here, the b is this side, which means we're going to take out the negative 2y into, if I take out the negative 2y, this must come first, which is going to be a 2b minus 5c. Take out the 2b minus 5c. I'll be left with 3x minus 2y as my result. Okay. Question number 3, equations. So the first one is a linear equation. They're telling us that x minus 3 is 21 minus 5x. Let's move this one to that side. So x plus 5x is 21 plus 3. 6x is a 24. Divide both sides by 6. X becomes a 4. Then when you look at the second one, okay, 2 times 5 to the x equals 15. Let's start by getting rid of these 2. So over 2, meaning that 5 to the x is a 25. How do we write 25 as a base of 5? So 5 to the x equals to 5 squared, meaning that x is a 2. And then 3.1.3, 3 to the x minus all of this. So whenever we have a minus or a plus sign in between exponents, we need to factorize. So let's write it this side, 3 to the x minus 7 times 3 to the x plus 1 should give us negative 540. Okay, so let's do the splitting here, and we shall have, that would be a 3 to the x minus 7 is going to be 3 to the x times 3. I'll say plus 540 is 0. Would this make sense? Now, let me just keep the 540 that side. Okay. Let me keep the 540 that side because it might give me issues. It may give me issues. Okay. So let's take out the 3 to the x. I'm going to be left with 1 minus a 21 because 7 times 3 is a 21. Negative 540. 3 to the x is going to be negative 540 over negative 20. Okay, so 540 divided by 20 gives us a 27 positive, meaning that 3 to the x is the same as 3 cubed. Drop the bases, x should be just a 3. Okay, so that is 3.1.3. Then 3.1.4, this is a cubic equation, but there's something common. Let's take it out. Shall have x squared minus 3x plus 2. Now we have a quadratic in there. meaning that it's x into x minus 2, x minus 1 equals 0. So with this dot product, the first x should be a 0. This bracket gives us x as a positive 2. This bracket gives us x as a positive 1. So since the highest degree is 3, meaning that we should expect 3 answers. All right, then 3.2. 3.2. They are telling us that Jabulani is an upcoming entrepreneur. Orders a total of 74 bags of t-shirts and hoodies. Okay, he pays $230 per t-shirt or per bag of t-shirts, and then $500 per bag of hoodies. How many bags of t-shirts did he buy if he spent a total of $12.90? So this is more or less the same question as that of the sheep and the goats. Okay, so let's see. We're gonna keep the letters hoodies and t-shirts now. So you're saying that if we get the t-shirts T plus the hoodies, we must get 74. But this guy spent $230 per the t-shirts. So 230T plus 500 for the hoodies, 500 each. It should give us 12,290. Equation 1. Equation number 2, it's up to you. You can do the substitution or the elimination. I'm going to multiply this by, let's say 230. So 230T, 230H. What is 74 times 230? That's gonna be 17,020. And then we subtract. Does that make sense? Okay, this is equation number 3. Does it make sense? 500 per bag of hoodies, 230 per bag of shirts. And then the total is 12,290. Okay. Up to 19 is what we are getting. 17,020 is what we are having also. Then if we try to do the subtraction, why is it that this question is not making sense for me? What am I doing wrong? Okay, let me just suspend that. Let's try the substitution and see. Something is not adding up. T is gonna be 74 minus H. Let's put this here. So 230 into 74 minus H plus 500H gives us 1290. Let's see if we're gonna arrive at the same thing. So 230 times 74, 17,020 minus 230 plus 500, this is H, is 12,290. Okay, when I subtract this, it's going to give me 270. 230 minus 500 is a 270. Then 12,290, we're subtracting 17,020. Gives me a negative 4,730, which means there's something wrong with this question, because there's no way on earth we can get negative number of bags. Okay, and moreover, it's a fraction. So something is off with Mr. Jabulani's question here. Either the numbers are not adding up or something, but probably this total is wrong. And then if the bag of t-shirts contained 5 t-shirts and that of hoodies contained 5 hoodies, I feel the profit that this guy will make if he decides to sell the t-shirt and the hoodie at 105 and then this. Now, it's going to be hard for us to answer this question because one, we failed to find out how many bags that he bought for the t-shirts and the hoodies, because that would in turn give us the total amount that he spent on each item. All right, so that kind of brings us to the end of the 10 questions. But remember, there could be also some elements of trick. Please follow the videos that we've done before and see how the trick can be answered. Thank you very much, and I wish you all the best in your exams. Bye-bye.